Sri Lanka has a well-earned reputation as the gem capital of the Indian Ocean. It is one of the few places on Earth where world-class sapphires, rubies, and rare color-shifting alexandrite are regularly pulled from the river gravels. But the island also exports a second geological treasure, ultra-pure crystalline vein graphite, which miners have extracted from deep, narrow shafts for over a century. Usually, a concentration of mineral wealth like this is the byproduct of violent, active volcanism, pushing magma to the surface. But Sri Lanka doesn't have a single active volcano. The lush, tropical greenery covering the island is a distraction. Beneath the jungle floor lies a massive, inactive geological engine, hidden completely out of sight. To find the source of these deposits, we have to look past the topsoil and investigate the island's deep crystalline basement. These riches were forged by an ancient geological machine, locked miles beneath the jungle floor, long before the first tropical rains ever fell. We have to rewind 500 million years to the Pan-African orogeny. Earth's ancient landmasses collided to form the supercontinent Gondwana, with the Proto-Sri Lanka region caught directly in the center. This continental pileup drove surface rocks deep into the crust, subjecting them to blistering heat and immense pressure. This tectonic vise baked most of the island into solid Precambrian metamorphic rock, forming a distinct central band called the Highland Complex. The extreme conditions recrystallized the existing rock into dense gneisses, marbles, and a dark orthopyroxene-bearing bedrock called charnockite. This environment, the terrifying heat and pressure of two continents colliding, is precisely what cooked carbon into pure vein graphite and crystallized aluminum into raw sapphires and rubies. That ancient collision acted as a planetary-scale pressure cooker. It manufactured an immense amount of wealth, but left it trapped inside miles of solid rock. But minerals forged inside miles of solid Precambrian bedrock are effectively out of human reach. For these stones to end up in a jeweler's window, something had to physically dismantle the mountain. Over millions of years, the tropical monsoon system has acted as a relentless wrecking ball, battering the steep, exposed peaks of the Central Highlands. The rain acts as a chemical solvent. The water breaks the solid crust down, dissolving minerals and leaching the rock into thick, nutrient-poor, red-yellow lateritic soils. Then physical transport takes over. Heavy downpours wash away the fine silt, while the newly freed, much denser gemstones are dragged downhill toward the coast. These heavy crystals drop out of the turbulent water, settling into thick layers of alluvial gravel in the lowland basins, most notably in the Ratnapura district. The hydrosphere operates as a massive natural mining operation, pulverizing the deep rock and transporting those ancient riches directly to human hands. But there is a cost to this geography. The same forces that grant Sri Lanka its wealth are also responsible for its greatest natural hazard. Chemically weakened over millions of years, the deeply weathered metamorphic soils and steep mountain topography make the central bedrock inherently unstable. During the intense southwest monsoons, sustained rains saturate these slopes. The water eventually overcomes the internal friction holding the soil profile together. This sudden failure routinely triggers massive, deadly landslides that tear down the mountainsides, devastating the central highland districts. This loop tracks the exchange between the geosphere's weathered rock and the hydrosphere's rain, two parts of a single, interconnected cyclic machine. The human settlements in these hills are simply participants in that loop. Our survival depends on navigating the rules dictated by the bedrock and the rain. Sri Lanka is a living piece of deep time. Every mined gemstone and every landslide proves that a tectonic collision from 500 million years ago is still actively dictating the present.